good morning to one and all present here. I am Dr. Jude, Assistant Professor, Department of Chemistry, Sacred College, Autonomous, Tirupattur. Today we are going to discuss about thermodynamics, which is Unit 4 of your syllabus. Before going to the thermodynamic part, we'll see the syllabus and objectives. Unit 4 comprises of 4 subunits, and the 4 subunits are: the first one, terminologies in thermodynamics; types of system, surrounding; types of system, surroundings; types of processes; and 4.2 is first law of thermodynamics and its application, enthalpy of processes, and what is the limitation of first law, and also zeroth law of thermodynamics. 4.3 comprises of second law of thermodynamics, its application, Carnot engine, and of course calculation of efficiency. 4.4, which deals with concept of entropy as a criteria for spontaneity, statement of third law of thermodynamics, and these 4 subunits comprises the unit 4 as thermodynamics. First we will start with the definition. Thermodynamics is the study of flow of heat or any other form of energy into or out of the system. If there is a system, there is an energy in the form of heat which is going inside and also it is coming out. In this process, it undergoes a physical or chemical transformation, and this is called as thermodynamics. Basically, it is a flow of energy, and in this flow of energy, certain properties of the system is changed. Say for example, temperature, pressure, volume, and concentration of the system is varied. Basically these 4 is varied, and many more properties is also varied, and we take this 4 is going to be the very important one. And laws of thermodynamics, and what is the scope of this thermodynamics. So basically, to have a idea about our study of thermodynamics, we have 3 laws: first, second, and third law of thermodynamics. And what is this scope of thermodynamics is, it tells whether a particular physical or chemical change can occur in a set of conditions. Say for example, temperature, pressure, and concentration. If it is varied, what kind of physical or chemical change it will come. It also helps in predicting how far a physical or chemical change can proceed. When the lowering of energy can take place, the chemical reaction ends or a physical change ends, so that it establishes an equilibrium condition. So that is the second one. Third scope is most of the important laws of physical chemistry, that is Van 't Hoff law of lowering of vapor pressure, phase rule, and distribution law can be derived from law of thermodynamics. So that is an important application, because important laws of physical chemistry can be derived. In this particular slide, we'll define what is a system and what is surrounding. A system is that part of an universe which is under thermodynamic study, and the rest of the universe is called as surroundings. See, in this diagram we have a system which is given in a box, an entity. It is surrounded by a boundary, definite boundary, and the blue part is called as system. The blue part is called as system, whereas another colored part, it is called as surrounding. So I can give an example for this. You just take a cup of coffee, right? So this cup of coffee, the coffee content is a system. The cup is called as a boundary, and if it is placed in a closed environment, then it is going to be, this environment is called as a surrounding. and it is not a closed environment. Some environment it is kept, and this system is called as an open system. In the same thing, this cup of coffee, a coffee is taken in a flask. Then inside the flask there is a coffee which is called as system, and the flask is called as boundary, whereas this one is called as a surrounding. And this is an example for closed system. So we started with the syllabus and the objectives, and there is going to be 4 subunits, and we saw the definition of thermodynamics and the laws of thermodynamics and the scope of thermodynamics, and lastly system, what is system, and surrounding definitions. Thank you.